Imagine this: a spacecraft drifting farther from Earth than any human has ever traveled. No cities, no signals, no quick way home. Just 4 astronauts and a tiny blue planet fading into the darkness behind them. Over 50 years ago, Neil Armstrong took humanity's first step on the moon. Since then, we've sent robots across Mars, launched probes beyond Pluto. But humans, we never went further. Until now. Because for the first time in a generation, we are about to push human exploration beyond its limits again. This is Artemis II, and it's not just a mission. It's the beginning of something much bigger. A mission that changes everything. NASA is preparing to send 4 astronauts on a journey around the moon, farther than any human has ever gone. Not to land, not yet, but to answer one critical question. Can we survive deep space long enough to stay there? Meet the crew. Leading the mission is Reed Wiseman, a former Navy fighter pilot turned astronaut. Beside him is Victor Glover, who will pilot the spacecraft. Mission specialist Christina Koch holds the record for one of the longest space flights in history. And Jeremy Hansen, on his very first trip to space, will become the first Canadian to journey to the moon. 4 people, 10 days, one mission that could redefine human exploration. The most powerful rocket ever. At launch, they'll ride aboard the Space Launch System, SLS, the most powerful rocket ever built. Think about this. More thrust than any rocket in history. Engines derived from the space shuttle era. Twin boosters generating millions of pounds of force. When it lifts off, it won't just shake the ground. It will light up the sky like sunrise at midnight. Their lifeline in space. The astronauts will live inside the Orion spacecraft, their home, shelter, and survival system. Compared to Apollo capsules, Orion is larger, safer, built for longer missions. Inside, astronauts will sleep in microgravity, exercise daily to prevent muscle loss, eat rehydrated meals, and yes, use a real space toilet, finally. But beyond comfort, Orion is designed for one thing: keeping humans alive in deep space. The journey. After launch, the crew won't head straight to the moon. First, they'll orbit Earth in a stretched, elliptical path, testing every system: navigation, life support, thrusters. If anything goes wrong, they come home. If everything works, they fire their engines and begin the journey outward. This maneuver, called translunar injection, sends them towards the moon using a free return trajectory. Meaning, even if everything fails, gravity will bring them home. Around the far side of the moon. About 4 days later, they reach the moon. But here's the twist. They won't orbit it like Apollo missions. Instead, they'll swing wide around it, traveling nearly 400,000 kilometers from Earth. From that distance, Earth becomes a small glowing marble in the darkness. A view first captured during Apollo 8 mission in the famous Earthrise photograph. And now, a new generation will see it again. The most dangerous moment. After the flyby, the crew begins their journey home. But the hardest part is still ahead. Re-entry. Traveling at over 40,000 kilometers per hour, their spacecraft will slam into Earth's atmosphere. Temperatures will reach over 2,700 degrees Celsius. That's hotter than lava. Their survival depends entirely on a heat shield, working perfectly. No margin for error. Here are some mind-blowing details about Artemis II. Deep space radiation risk. Outside Earth's protective magnetic field, astronauts are exposed to cosmic radiation. To prepare, they'll test an emergency shelter built using food supplies and equipment as shielding. Modern tech in space. For the first time, astronauts may carry modern devices like smartphones into deep space. Imagine capturing moon footage on something like your own phone. Exercise is survival. In microgravity, muscles weaken fast. Astronauts must work out every day or risk not being able to walk when they return. Power in space. The Orion spacecraft's solar panels generate enough energy to power 2 average homes on Earth. A test for the future. Artemis II is not the final goal. It's a test mission for something bigger. Permanent lunar bases, deep space stations, and eventually missions to Mars. So here's the real question. What happens if Artemis II succeeds? Because this mission isn't about flags or footprints. It's about proving that humans can live, work, and survive beyond Earth. And if we can do that around the moon, what's stopping us from going even further? Mars, beyond, or places we haven't even imagined yet. Because this might not just be another mission. It might be the moment humanity truly becomes a spacefaring species.